Here is the key for quiz 5. Another roadmap problem. We are asked to fill in the boxes here as we go from the 1-pentene to this much more fancier aromatic substituted compound. So in order to get to this primary alcohol from 1-pentene, we need my favorite reaction, BH3THF, followed by base and peroxide. And that is from first semester organic chemistry. Then PCC plus a primary alcohol gives us the oxidized product, an aldehyde in this case. And then I want to take this 5-carbon aldehyde. Looks like I have 5 carbons right here. So I need to add this aromatic ring and end up with a secondary alcohol. So I need a phenyl Grignard. That's step 1. Step 2 is mild acid workup. And then I have a number of boxes that are empty. I take this secondary alcohol with a phenyl ring on one side. I turn it into a ketone with a bromine on the phenyl ring. So what I need to do is somehow change this substituent into a meta-director and then install the bromine. And if I change it into a ketone, as we see here, we know that that is a meta-director. So I should oxidize it first. I can probably just use PCC again for that. Now I have a acyl benzene ring, and I can add bromine in the meta position with Br2 and FeBr3, and then I have my desired product. Question 2. This asks again about acidity, and so we're going to look at these alcohols in terms of their acidity. There is no resonance stability available for any of the alkoxides that might be formed on any of these, so resonance is not going to play a role. We do see a difference in steric bulk between the middle one and the two outside, and I see some inductive effects from these chlorines here. So the one with inductive effects should have the most acidic hydrogen, OH group, and the most bulky OH should be the least acidic. Again, because when we form this compound, we get a bulky alkoxide. It's harder to stabilize that via solvation with this large bulk. And that would give 2 for this propanol. All right, for 3, we're asked to fill in reagents or starting materials for these incomplete reactions. Here we're taking a alkyl group, turning it into a carboxylic acid, and we can do that with the sodium dichromate oxidizing reagent, Na2Cr2O7. For B, we're asked to take this primary alcohol and turn it into a carboxylic acid. We can do that also with chromium reagents. Let's use Jones reagent in this case, H2CrO4, mixed with water. That will give us a primary alcohol oxidized to a carboxylic acid. And the second one here is, looks like we need to fill in the starting material. We're reacting a ethyl Grignard followed by mild acid to make this secondary alcohol. We know that Grignards can make alcohols, so we either make this bond or this bond. And since right here is a 2-carbon species, I'm going to say that we should have started with a 4-carbon aldehyde. React that with the Grignard. And lastly, we are asked to come up with the starting material, react sodium borohydride and ethanol to make this secondary alcohol. And we know that this is a reducing agent that provides H- to take carbonyls to alcohols. So in fact, we should have added the hydrogen that is not drawn right at this position. So let's redraw the starting material without a hydrogen at that position and a double bond. And so that would be the starting material I'd expect for that reaction. Moving on to number 4. We're asked for a reasonable arrow-pushing mechanism for this reaction, and we're given 2 equivalents of methyl Grignard and 2 equivalents of mild acid workup then at the end. And this is a lactone, but more generically it's an ester. We know that Grignards add to esters, so let me draw my Grignard a little bit more carefully. This is simply a Grignard addition to an ester. And then the second step is loss of the OR group. And here we're not really losing it because it's still attached. And now I have a ketone I can add my second Grignard to. And I end up with 2 alkoxides now. And I can proton transfer or protonate both of those. So let's get H3O plus in here. I'm going to show them one at a time. There's my first, and then here's the second proton transfer to get to the product. And you can straighten out the chain and you'll get the straight chain version right here.